Hello students, so let's try to solve one more problem from CSIR NET examination, and this is a question number question ID 452. So it's a very nice problem, and this problem is related to classical mechanics, and we have to calculate the equation of motion of a system. So what is system? So there is a spring in a vertical direction, and the end of a spring there is a pendulum mounted, and this spring is moving as a function of time, and which is given by the height is moving as h naught 2 cos omega t, and where h naught is greater than L, and we have to write the equation of motion. So students, what I have to do, we have to just go for first writing your basically a Lagrangian of a system, and after then we have to just go for equation of motion. So it's a lengthy problem, you have to solve it step by step. So let's try to solve it first, and then we can easily analyze. So let's try to go for this one. What we have basically this is our, so there is some platform, and here we have a spring, and there is a pendulum, and what we have to do, this height is h, this height is h, and this angle is theta, the length is L. So what will happen, this height is nothing but L cos theta, and this height is nothing but what, L sin theta. So what we have basically x is equal to L sin theta, and y is equal to ht plus L cos theta, and we can put the value of ht, and this value is equal to h naught 2 plus cos omega t plus L cos theta. So what we have to do, we have to just write the kinetic energy of a system, and this kinetic energy of a system is half m x dot square plus y dot square. And what is my potential energy of a system? The potential energy is mgy. So we have to just calculate what is x dot as well as y dot. So x dot is equal to L cos theta, theta dot, y dot is equal to h naught omega with the minus sign, sin omega t minus L sin theta, theta dot. So what we have to do, first we have to write the kinetic energy part. So when we will write kinetic energy part, so kinetic energy can be written as half mx dot square plus y dot square. So what we have, x dot square plus y dot square. So in the y dot square, this is a square b square plus 2ab, because these two are minus sign. So that will be plus here. So what will happen, L square cos square theta dot square and L square sin square theta dot square is equal to, you can easily write half m L square theta dot square. And then you have this one square also. So this value is equal to h naught square omega square sin square omega t. Now we have cross term, and that will be plus. So we have 2 h naught omega sin omega t L sin theta, theta dot. So this is my kinetic energy, and then we have to write the potential energy. The potential energy is mgy, and that value is equal to mg, and y is nothing, h naught plus, that is actually this value is h naught 2 plus cos omega t plus L naught cos theta. So this is my kinetic energy, this is my potential energy, and then we have to go for Lagrangian of a system. So let us try to write the Lagrangian of a system. So when we will write the Lagrangian of a system, and this is nothing but we have half, so this value is equal to half m L square theta dot square plus H naught square omega square sin square omega t plus 2 H naught omega sin omega t, and we have basically sin theta theta dot, this is kinetic energy, minus mg y naught plus we have, this will be something like minus mg y naught 2 plus cos omega t minus mg L cos theta. So, this is our Lagrangian of a system. Now, it is a very lengthy Lagrangian. So, we have to go for equation of motion, and once we will go for equation of motion, we have to start from d upon dt del L upon del theta dot minus del L upon del theta must be equal to 0. So, when we will go for del L upon del theta dot, then what is going to happen? Del L upon del theta dot. So, first we will go for del L upon del theta dot separately. So, this value is equal to m L square theta dot, and in the second term there is not any theta dot, we have in third term we have theta dot, and this 2 and 2 will cancel. So, what we have plus h naught omega sin omega t and sin theta. Now, we have to go for this term d upon dt del L upon del theta dot. So, what we have? We have d upon dt del L upon del theta dot. So, this is total derivative with respect to time. So, what we have? M L square theta double dot, and here we have to go for differentiation with time. So, first term we are going to differentiate with sin omega t. So, we will get h naught omega square cos omega t, and this value is equal to sin theta, plus we will take this value constant. So, this is your h naught omega sin omega t cos theta theta dot. So, this is our del L upon del theta dot. So, d upon dt del L upon del theta dot. Now, we have to go for del L upon del theta. So, when we will go for del L upon del theta, then there is not any term of theta, but here we have one term of theta, and that value is equal to h naught omega sin omega t cos theta theta dot. So, this is very interesting, and second term will be here. So, this term will be gone. So, there is not any problem. So, we have minus, and we will have m minus mgl sin theta. So, what we have? We have h naught omega sin omega t cos theta theta dot plus mgl sin theta. So, now what we have to do? We have to just write this one d upon dt del L upon del theta dot minus del L upon del theta must be 0. So, this term we have taken. So, we have to take the minus term here. So, when we will take minus term, so we will just go for minus term here. So, I am writing it correctly, m L square theta double dot plus h naught omega square cos omega t sin theta plus h naught omega sin omega t cos theta theta dot minus. So, here we have minus sign h naught omega sin omega t cos theta theta dot minus mgl sin theta. So, what will happen? This term and this term is cancel out, and that must be equal to 0. So, what is my answer? My answer is m L square theta double dot plus h naught omega square cos omega t sin theta minus mgl sin theta must be equal to 0. So, this is my answer. So, I think let us try to go for which is going to match with this one. So, I think g sin theta, negative sign is there, and 1 sin theta and cos omega t, I think this one is there. So, cos omega t sin theta. So, you can take L common. So, this value is the correct answer. So, this 2 number is the correct answer. And it is a wonderful problem, wonderful problem. You cannot guess this type of problem because there is coupling term and all each and everything, and this is worth for 5 marks. Okay? So, students, you have to solve this problem yourself. If you have any suggestion, let me know. Thank you.